And after that, I will introduce you to our speakers, and then all the stage will be on his side. So we are Women++. We are an association that is based in Zurich, but trying to cover all different regions in Switzerland. And indeed, I'm based in Lausanne, actually, with Patricia as well. Our goal is to bring a more inclusive and more diverse environment into companies, but not only companies, and try to support people in introducing different concepts in the technological domain. And this is one of the reasons we are trying to let's say, organize these different webinars, is to provide and to support people that are curious about different type of topics in the technological domain to get an intro to this. So today we are going to hear Dr. Benjamin Rusell speaking us about two interesting features in Python, list and list slices, and he will give you an interesting overview of them using a Jupyter notebook, as you will see in a couple of minutes. Just a few words about Dr. Benjamin Rusell. So he holds a PhD in computer science from University of York, UK. After that, he moved to Princeton to do postdoc on operation and research. And while there, he started also his journey as a trainer and a tutor in, let's say, data science domains. And indeed, when he moved here in Switzerland, one of his main activity has been focusing on helping people get into the field of data science. And indeed, he is founder of Python Rocket Upskill here in Switzerland. So I'm really happy that he joined us. Yes, Rocket Upskill, sorry. I'm really happy that he found the time to join us and to give this talk. So I don't want to take more of your time, and I want to welcome him to the webinar. Just one last thing about how the webinar works. So especially regarding questions. So you can ask questions through the chat. We will try to answer those questions directly on the chat. If we are not able, or there are too many questions, then we will take some time during the explanation to directly ask live from the speaker's voice. Okay, now I think it's time for Benjamin to take the stage.
So thanks a lot for that nice introduction, Marta. So can everyone see can you see what I'm sharing, Marta? Can you see the notebook?
Yes. Yes.
Okay, so what everyone needs to do to access the notebook, I believe Marta shared the link to mybinder.org. So what we need to do is, everyone who wants to follow the workbook through, you're welcome to just watch me click through it. But anybody who would like to follow the workbook through and run the cells with me or complete the missing exercise steps needs to open mybinder with the link that Marta can share as well. So anybody who wants to do that, I think that's the GitHub link. I think you need the other one. I think you need the link, which is the one for Binder.
Yeah.
I tested the one you sent and it worked great. So if when you click the link Martha's about to share, you might experience some kind of error that says something along the lines of this kernel is deactivated. There's a very obvious massive button that just says resolve this or something. And then you should get to a notebook which looks exactly like mine, and you should be on your own copy of it. So let's just give everyone a moment to do that. If anyone's trying to do it but cannot, just mention in the chat, I guess.
Yeah, it's actually throwing an error, forbidden.
Your server appears to be down. I think, Marta, if you recreate the binder link, you just go to my binder and put that GitHub in.
Yeah, Chris,
You know
can you
what?
do that?
I think I can maybe do it. Let me see. So if anyone wants to do it for themselves, you can just go to this link here, and then you can copy paste the GitHub link, which is this one, into the box which says GitHub link, or something to that effect. And then there's a big obvious button which says launch, it's orange. That should also work for you. I think giving everyone one link tries to connect them all to one kernel. I think everyone needs to do it themselves, now that I think about it.
Yeah, maybe you can explain what is Binder, just to give...
Yeah, sure. So Binder is just a place to run Jupyter notebooks in the cloud. So it's a place where you can, it's like Google Docs, but for Jupyter notebooks. It's also free. So it's just a nice way for everyone to access a copy of the notebook. It's okay if you can't access it, you won't really miss much. But it is good to practice interacting with Notebook because it is a very standard tool.
Because otherwise you should actually have installed Python and Jupyter Notebook on your laptop. So actually using Binder, you don't need to have anything installed locally. Okay. Now it's working. Please.
Okay, great. Okay, so let's start from the beginning. So hi everyone, and welcome to this seminar about unique iteration strategies in Python. So as you already know, I'm Benjamin, and I'm giving today's talk, and thanks to Marta for the invitation to do this. So Python is a uniquely intuitive language. So today we're going to look at ways to simplify looping in Python using two features, list comprehensions and slices. So once everyone's got the notebook up and running, or if you don't want to do that, it's no problem. We can start to go through the cells of the notebook. So I think everyone here has got some very elementary experience with computer programming. So maybe you've seen what for loops are in other languages. So for loops exist in Python as well, and they're nice, and they're an intuitive way to iterate over sets or lists of things. And a very large number of, in quotes, imperative programming strategies require this kind of design pattern. So if you've ever used MATLAB or C++, you'll probably be very familiar with needing to do a loop over a set of things. So how do we do this in Python? Python has its own way of doing that that's very similar to other languages. So we can define a list in a way that's not particularly exceptional. So I can call my list in a thing, and I've chosen to call it L, is equal to, between square brackets, a list of comma-separated things. And here I've put numbers into the list, but you needn't have done that. This is how you do a simple for loop using the for plus in pattern. So in Python, you should notice that a tab, an indentation, decides what's inside the loop. So unlike in C++, where you'd have curly braces or an end statement in MATLAB, indentation defines what's inside the loop in Python. So if we run this first cell, we can see that. So for k in L, and then a colon, and then something indented. The thing which is indented here, if everyone sees I'm selecting, this line 9 in the cell, this is what's going to be looped. The thing on line 11 will not be looped. And the reason is the tab here. So in Python, we don't have these curly braces to define what's inside the loop. We define it by indentation. And this can be confusing initially. Once you get into the habit of it, I prefer it a lot to the other alternatives. So lists in Python are also polymorphic. So this is a word with Greek origin that means something a bit like many shapes or maybe many forms. This means we can put anything we want into the same list. So numbers or strings or other lists, lists of lists, or whatever you like. This is unlike many other languages like C or C++, where you can't typically do this out of the box. So Python is very, very forgiving, let's say. If you guess, you're likely to guess something that will run. So I've got a list here, 1, 2, 3, blah, blah, pineapple, another list, true, 999, and these all just sit in my list and they work just fine. I can iterate over them as if they were just single numbers. There's no special rule I don't have a special kind of list to put lists of strings or anything like that. So unlike MATLAB syntax, which would be like this, or C++, which would look something like this, notice I've got this for and end, and the indentation isn't doing anything, it's just to make it look pretty. Or I've got these curly braces to say what's inside the loop. Here it's just this tab. Okay, so in Python we can iterate or loop over anything which is iterable. So it sounds a bit of a tautology, but some types in Python are iterable. This means things that we can loop over. So this includes the intuitive things: sets, strings, lists, dictionaries, tuples. And mostly these are just kinds of list in the end. I would say only dictionary is really its own thing. We're going to see some examples. So here's an example of looping over a set. So instead of using square brackets, I use curly braces to define this. And the only difference is the set cannot contain duplicates, unlike a list. I can put the same thing twice into a list. So for example, if I compare these two lists here, there's two options here. This is a list, 1, 1, 1, 2, and I get 1, 1, 1, 2 back. If I put that into the braces, the duplicated ones are just collapsed down to 1. So there's no duplicates inside a set. But other than that, it behaves exactly the same. So I can put my objects into my set with curly braces instead of square ones, and I can loop over them all the same. So the thing to keep in mind is just that the two things are almost exactly the same, except the set doesn't contain duplicates, just like in mathematics. We can also loop over strings in Python as if they were lists. So a string in Python is also not really a special kind of thing like it is in other languages. It's actually just a list of characters, which makes sense intuitively for what a string is. We can loop over that too, in exactly the same format, and it does exactly what you'd expect. It's going to list the characters in the string in order that they appeared. And we don't need to adapt the syntax that we use to do that. So if we want to select a subset of the list we're iterating over, in the normal way of doing this, we need to use an if statement inside our for, inside of our loop. So say I wanted to select all the even numbers between 1 and 20, and obviously this isn't how you would actually do that. It's a toy problem to explain the concept. I would create a list like this. This is how you would create an empty list with these square brackets with nothing inside of them. Call it res for result. We're going to do a loop of all the numbers between 1 and 20, and the upper limit here, when you loop over a range of numbers in Python, is not inclusive. So if you want 20 to be in, you have to put 21 here, and it's a very common cause of bugs. It's just a stupid thing that you just have to remember. When you put range, the upper limit is not included, so you have to go one more. And we can test if a number is even or odd with the modulo operator. We can say if our number we're looping over divides by 2 evenly, then we put it in the result list, and bingo, we run that, we get exactly what we would expect. All the even numbers between 1 and 20. So the thing to remember there is the modulo symbol is, I think if is fairly self-explanatory, but the modulo symbol in Python, like many languages, is a % sign, and you can think of it as a remainder. You remember long division from school. So this is going to do what we intuitively expect. So 10 divided by 2 has no remainder, but 11 divided by 2 has remainder 1, 3 divided by 10 has remainder 3, so on, so on, so on. So when I do this modulo 2, I just get the answer if it's even or if it's odd. Okay, so if the remainder when divided by 2 is 0, then we have an even number. So yeah, we can see an example here. So specifically, x mod 2 tests if x is even or odd. So if we wanted to create a list of all the odd numbers from 1 to 20, we would follow exactly the same pattern. And if you want to try it yourself, you can try and fill in the cell if you've got everything working in Binder. If not, you can just follow me as I do it. We're going to create the list where we put the result. And say for, it's always the same pattern. For, then my variable, then in, which is just reads like an English sentence for all the values k in the range. That's range. Remember, this is not inclusive. If the remainder when I divide by 2, is 1, and we append. Okay, so the only difference is the remainder being 2, being 1, sorry. And here we go, we get all of the odd numbers. This is a perfectly good way to solve this problem. It's a little bit clunky, it's not very beautiful, it's not very intuitive. If I wanted to do the same thing to capture all the multiples of 11 and 7, I would have to do this. I have to say k in range 21. I've set to 100, so I'm going to put 101. Remember, you always have to do that. If k mod, I said 11 equals 0, so if k divides by 11, append it. Append means add to a list, in case that was unclear. If k mod 7, 0, append it. And we look at the result. So we get this massive list of all the numbers that are divisible by 7 and 11. Okay, so that makes sense. We had to do 2 tests inside of our loop. If you read through the logic of the code, it's completely logical, but it's not a very elegant way to solve it. So this is how you would solve it in MATLAB or in C++. Python has a special feature that lets you, because this kind of issue comes up so much, Python has a special syntax which makes it more intuitive. So many times when we loop through a list of objects, we want to act on them, or transform them one by one. For example, if I want all the squares for a list of numbers, I could do this loop, very similar to what we just did. A list of numbers, create an empty list to store the result, loop through the list L, and append the square of every number. I run that, okay, we get the result. I get the square of every single thing here. But this requires looping over them one by one, and it requires creating this extra list here, which is somehow a waste. And everyone can agree that waste is bad, but waste is bad in software engineering as well, because it creates code which is difficult to maintain, difficult to read, difficult to explain to other people, difficult to debug, and it also wastes memory when it runs. So when we only have the numbers from 1 to 6, that's not a problem. But if you become a data scientist, you have data sets that have 1 million data points in them, then it can be a very significant problem, because if you solve a problem in an inefficient way, even if the algorithm is correct, you may wait for hours and hours, or it may never finish. So it is important to learn the elegant ways to solve problems that are more efficient. So Python offers a neat syntax for implementing this pattern. The form might be familiar to anyone who has a math background, because it's similar to what mathematicians call set builder notation. If not, don't worry about that at all. And just a quick aside is that in Python, to raise a number to a power, it's a double star, not the pointy arrow, not the caret. So 10 squared is written like that, not like that. If you write this, you'll get a completely different result. And it's a gotcha, because it's a common cause of mistakes, because people think that it's the caret symbol, the pointy arrow symbol, but it's not. It's double star. And the caret exists. It just does something completely different. I think we should not go into what it does. I think if you're really awake, you might work it out from just these 3 examples. Put it in the chat if you have a guess. But it's not going to raise it to the power, because 2 to the 10 is definitely not the same as 10 to the 2, right? And they're definitely not 8. Okay, so how can we do this a different way? In Python, I've got a syntax called a list comprehension. So I can define my list directly as before, or I can use one of these ranges, which does essentially the same thing. This just makes it a list of all the numbers between 1 and 7, not including the last one, but it will include 1. And instead of doing my loop, I can just put everything directly inside my list like this. So this is a comprehension. So the pattern is enclosed between square brackets, just the same as when we made the list in the first place. Square brackets, the function we want to put inside the list for k in the list of things we want to loop over, like this. And now, and even more clearly, you can put the range inside the list like this. So now, in this syntax, this one line of code does everything which this entire block of code does. And I think that's very much clearer, because when you look at it, you can just say, you can read it like a sentence almost. It says, give me a list of the numbers k squared for every single k in the range 1 to 7. Whereas if you were given this piece of code, you'd have to go line by line and work out, it's much less obvious what that's doing. And even in these very simple cases, I'd still have to read through this block of code. Whereas this is far easier to just read in one go. So this is an example of a list comprehension. And we can do much more complex things with list comprehensions. So I can do comprehensions for anything in Python, anything that can go in a list. So we saw before that lists are polymorphic. It's not just numbers that will go into lists, it's anything, any valid Python object, including other lists. So if I have a list of strings like this, qualities that we want our code to be, we want Python code that's clear and readable. If I use a plus symbol in Python, it means to concatenate strings, to just join two strings together. So I can create a new list of every single element of my list L, concatenated with the word code, like this. So it's going to give us a list of strings like this. I could even have done this in one step by putting the list L inside here. I could just substitute it in. And I'd have this one-liner here, which would do that pattern instead of having to copy this schema every single time. So I think that maybe explains what the point of a comprehension is. But I think it doesn't show what the full extent of using them to solve puzzles is. So if we take a look at, this is just another example of a comprehension that extracts the first letter of every single word. So this says, for every single string in the list L, give me the first letter of it. And there we go, it's another button. If I wanted the second letter of everyone, I could do this as well. So if we wanted to solve a puzzle with a comprehension, let's take a look at an example of a mathematical puzzle similar to the Project Euler kind of puzzles that I use for lots of teaching. If you don't know Project Euler, it's a great resource. But this puzzle is not from Project Euler, it's one from me. So let's look at two ways to solve the same problem side by side, and we can see that they get the same result. So let's look at one where we couldn't do it by guessing or just by on a piece of paper. So consider 100 monkeys lined up. I tried very hard to put a picture of a monkey holding a sign into this notebook, but it was a crashing binder, so I gave up on that. So 100 monkeys line up, and each monkey is holding a sign showing a number. Each monkey in the line is holding a sign that has the number on it, which is the square of their position in the line plus 6. So what is the sum of all the numbers held by monkeys in even positions in the line? So this is not something, unlike these other puzzles up here, where they're very basic. This is not something you can do on a piece of paper quickly or in your head. So if I were to follow the loop pattern, I would have to create a list to store the result. I'd have to remember the percent is modulo and the double star is to the power, not caret. And remember that monkeys start counting at 0 in Python. So always lists start indexing at 0. So we saw that up here, but when I selected 0 from the list, I got the first element. So in normal life, you start counting at 1 when you count things. Inside the computer, if you're not familiar with that, it always starts at 0. Okay, so we're going to loop over every number in range from 1 to 100. It's actually from 0 to 100. If you don't write the 0, it's assumed. We're going to test for all the even numbers, and then we're going to add to our results list that number squared plus 6, and then we're going to sum up the results list. Okay, so we get some number. So this works, just as the less complicated examples worked. But how would we do it with a comprehension? So we can include a condition inside our comprehension. So inside the loop here, we had to do this if statement to only single out the even numbered monkeys, because that's what the question asked us. But I can do that inside my comprehension as well. I can put that into here. So instead of having all of this, I can convert that into just this one line, which says, give me the sum of the comprehension that gives me k squared plus 6 for every single k in range, only if k is an even number. So you can read it almost left to right like a sentence, unlike this. So if we run this, we'll see that it gets exactly the same number. It will also actually run faster. So this is only doing up to 100, but if we increase the number that it's doing up to, it becomes a less trivial problem. And if you enable the time it plugin in Jupyter, if you know how to do that, you can compare the times these two codes take to run, and this one will certainly be faster because it's storing less intermediate data. Okay, so this is far better. I find the syntax far clearer, and I'm confident that with some practice, you'll find it far clearer too. So people who are converting from other languages, sometimes they have a hard time adapting to this because they're so used to the patterns in C++ and MATLAB, especially people with academic backgrounds who had to learn those languages or had to learn Fortran. But if you're a beginner, it's a bit of a blessing because you can kind of start the better way from now. So we can also apply custom functions inside of our comprehensions. So if I define a function, which in Python we do with the def command, def for define, I define a function called f that takes a number k in and converts it into k squared plus 6. So I can test this on its own. What number is the second monkey holding? Ooh, let's remember. So the second monkey is holding the number 10. The third is holding 15. The fourth is holding that. What's the 87th monkey holding? That number. So separating it out like this lets you test the steps one at a time, but still keeps the total result really compact and clear. And then I can run the comprehension like this by putting f of k instead of putting the formula into the comprehension. So suppose it was a really big complex formula. I might not want to have my comprehension rammed with something. I might want to just have 2 lines, one that defines the function neatly, and I can test it separately to check it's working. Especially if it's slow, I might want to test it one value at a time instead of trying 1,000 at once. So I can say in my comprehension, please give me f of k for every k in this range if k is an even number, and then sum all those numbers up in exactly the same way. So this is just an even neater way. If I put 1,000 there, we're going to get the same number as we get up here. So these codes are exactly the same. So this is even better in my opinion. It's even neater. And we can go one step further even. If I don't want to write a def, I can use an even more minimized way to define a function in Python called a lambda. So if this is a bit of an information dump, if we're going too fast with lambdas, there's more of an aside with the lambda. But the pattern comprehension plus lambda is very neat, I think. So we can define our function f is equal to this lambda, which means, lambda means map the thing before the colon to the thing after it. So f is just the same function as this function here. It's just a neater one-line way to do it. You can test that yourself. You can just test that if we make a new cell below and evaluate f, what was the line I tried, 87? Yeah, that's the same number as here. So it's doing exactly the same thing. So this is a very common pattern. Define a simple function by a lambda and put it inside a comprehension like that, where we say, give me f of k for k in some set that I care about for some subsets of k according to some condition. So this could be anything. You give me how many speeding tickets everybody in Minnesota has if that person is under 28 or something like that. Or how many fraudulent transactions are there for every account in the UK if that account was created in the last 6 months. So this is the kind of question you can ask with a comprehension that reads like a sentence still. Especially if you have a function which is accessing a database and doing a more complex thing. This is a very common pattern in data science. Okay, so this is a pattern. Yes?
Do you think it's a good time for the audience to ask you a couple of questions?
I think it is once we get to this line here, Marta.
Okay, very good.
It's about to get slightly trickier, and then it'll be definitely time for the questions.
So I want to renovate the invite to write on the chat and also tell us if you feel that Benjamin is going too fast or too slow, even.
Yeah, absolutely. So I don't have a good way. I don't have a good way to like measure that. So I've gone pretty quick, I guess, but I haven't got a good way to measure how people are finding that.
So yeah, feel free to stop him or tell us that we're going too fast. Speed is good. Okay. Yeah, so go ahead.
Okay, so the trouble is with that is the people who find the speed good, they're the ones who write that it's good, and then the ones, you know what I mean? But thank you for letting me know anyway. So let's imagine a much harder monkey puzzle. How would I do that with a comprehension? So one where you absolutely could not solve it with a piece of paper. So imagine 10,001, just to be awkward. Monkeys line up, each holding a sign showing a number. Each monkey holds a number that is the cube of their position in the line minus his or her position in the line modulo 1001, just to be awkward as well. Okay, so there's no way you can give me that number off the top of your head. So what is the sum of the numbers held by monkeys in even positions in line minus the sum of the monkeys in odd positions? Okay, so that's very much trickier. So if we did a loop condition to do this, a loop solution to do this, we'd follow the same pattern. We'd follow create our results list, loop over the full range, not forgetting that the end isn't inclusive, but that we also start at 0. We would test for the evenness of k, and then we would append the positive version of the number on the sign. For odd monkeys, I think monkeys is spelled wrong. I'm not sure. I wouldn't even know. We would test for the oddness of the number. So we check k mod 2 is 1. And if it is, we append the negative of the number on the sign. Okay, so this just happens to be the result of this game. However, we can do this in one go with a comprehension in exactly the same way. So I can say, give me the sum of this formula, which is the number on each monkey's sign, with a plus or a minus sign in front of it, whether or not it's an odd or an even number. This is a good trick to remember. Just do -1 to the power k mod 2. This will go +1, -1, +1, -1. So we'll capture which monkeys are in odd and even places for each k in this range. You can see these two expressions give exactly the same result. And I don't need to do this this complex splitting once I guess this formula. It's slightly separate from the comprehension, but it's still far neater as a solution. So just adopting this principle in general, you shouldn't let your comprehensions get so long and try and solve everything in one line. That's not the objective. The objective is to write clear code which reads as close as possible to a sentence, so it's easiest for somebody else who's new to it to understand. And also they say, code that you wrote more than 2 months ago is effectively written by somebody else because you will have completely forgotten.
Yeah,
yes,
so there's
somebody's asking the -1, yes. So yeah, we can explain it. So yeah, sure. So -1 to the power 0 is 1. -1 to the power 1 is -1. So this formula here is going to go -1. It's going to go +1, -1, +1, -1 as k increases. So that's going to give us a positive number like this for every even monkey and a negative number for every odd monkey. Basically, it creates this minus sign here. It's just a neat trick for doing that. The question is really right about that. I think it's not something that's obvious at all. I suggest that you go and try and play with that yourself, or we can see an example of what it creates on its own. So if we just do a quick comprehension, actually, we can do it like this. We can see it goes 1, -1, 1, -1, 1, -1 like this. So this is going to be used to add up to give a negative only to the, is it quite right? I think there might be an out by 1 somewhere, whether we're adding the odd or the even monkeys. But it comes to the right answer, so maybe it should be k plus 1 actually. So we can leave it as a homework to check it. I think there might be an out by 1. Maybe it should be k plus 1 here. But anyway, the principle is exactly the same. So -1 to the power k mod 2 goes +1, -1, +1, -1. And it lets us add up it should be letting us add up the even monkeys and subtract the odd monkeys. But it's actually doing the opposite. Seems to get the same answer in the end. So we could even go one step further in the syntax, and we could say define it through a lambda function and then do the same trick as before. Put f of k inside our comprehension. Yeah, it was a good question, and it actually found a mistake in the notebook. So if you want to fix that, you can figure out whether it should be k or k plus 1. I think it's k plus 1, but we'll come back to it. So we can define a function through lambda following the same pattern. And then we can say, give me the sum of my comprehension of every f of k for k in this range. And this is exactly the same trick and also gets the same number. So we see that we've converted this entire block of code into this 2-liner here with 2 clear steps that we can separately test. Okay, so if I wanted to create a list of all the odd numbers from 1 to 20 using comprehension, I would say take a few seconds to try to do that yourself if you're on Binder, and if not, you can just follow me doing it. So we're going to follow the same pattern. Square brackets to create the list. Okay, We just want the straightforward number, we're not transforming it. For k in range 21, remember, because it's not inclusive, if k mod 2 is 1. That's to say if it's even. And there we go, we get what we would expect. So we can also put, if we wanted to create all the multiples of 11 and multiples of 7, we could do that like this. Say k for k in range. And this is not the only way to do that, by the way. If you have another solution with a comprehension, there are certainly other ways. From 1 to 1001. If k mod 7 is 0, yeah, that's right, and it's going to be like this, or k mod 11 is 0. So I can put an or after the if like this. If I want two conditions, I can do that. So here we get all the multiples of 7 and 11. So this is going to work. It's going to include k if k mod 7 is 0 or k mod 11 is 0. So if I had two conditions, this is a way to select, put a more complex expression here. I can normally select the subset of my data. So maybe I want to look at the recent transactions of people who own a red car and live in Yorkshire, for example, or who have either one of those two things, who took a flight from the UK or from France. So it's a way to gather a data set from a bit like writing a query. So we could also put other logical expressions there. So if I wanted only the numbers which were a multiple of 7, 11 or 7, both rather, sorry, I could put an and here. I'm going to get a much smaller list. So these are numbers which are multiples of 7 and 11. Whereas this is the list of all the multiples of 7 and all the multiples of 11. So I recommend just playing through that. If you can solve it yourself on Bind, that would be great before you look at the solution. So Marta, did you want to stop for some questions now?
Yeah, I mean, if there is some question, I think it's a good time to ask to you. Otherwise, we can go to the next step.
Yeah, okay, yeah, it's okay with me.
So actually, I think that you are actually managing yourself in a very good way questions. So maybe we can you can do as we were doing so far. So every time there is one asking something, you can check on the chat if this is fine for you.
Yeah, it's no problem. Okay, so let's see how dictionaries work in Python. So dictionaries are another data structure in Python. It's a way to link keys to values. So it, again, like a set, uses these curly brackets, but the thing which goes inside is different, and this is what makes it a dictionary. So if it was a set, I just have something, comma, something, comma, something, comma, something. But I don't. I have something, colon, something, comma, something, colon, something. You can think of a dictionary like an address book. So if I wanted to look up somebody's phone number in the phone book, maybe you'll remember when those used to exist, you put the person's name in, and then gives you their phone number back. It's mapping the key as the person, the value as the phone number. It's exactly like that. So I can build a dictionary, and I can ask the dictionary with these square brackets. So you probably notice in Python, the square brackets have lots of different meanings, and you just need to learn them by practicing each of the different ways they're used. This is going to extract the value A because it's associated to the key 1. So the thing which goes here is the key, and the thing which comes out is the value. And if I ask for a key which doesn't exist, it's going to give me an error. It's going to say key error 2. There's no 2 in this dictionary. There's a 1 and a 3, but there's no 2. So it's like number not found. If I do this, we see that Z is the value associated to 3, and so on. So if I wanted to build a dictionary, which is something that you need to do all the time in Python or in all computer programming, basically, you might want to create a large dictionary mapping pre-computed values. But we can do this with comprehensions in Python, unlike in other languages. So if I wanted to create a dictionary mapping numbers to their squares, like 0 to 0, 1 to 1, 2 to 4, 3 to 9, people to phone numbers, license plates to speeding tickets, whatever thing it was that you wanted to do. We could do it like this. We could say D is defined as an empty dictionary. If you want to make it totally clear that it's not a set, you can put the word dict around it like that, but it's actually not needed.
There is a question for you, Ben.
No, it doesn't. So the question is, does it start with 0? It starts with whatever set of keys I put. So it doesn't actually start with anything. It starts with what. Okay, let me give you an example. So if I put blah and I put pineapple like this, and I run that, and I look up blah, all right, I'm going to get the same answer. It doesn't start with a number. It doesn't have an order like a list does. Yes, yeah, absolutely. It's not an array. So the list that let's talk about, let's say a list rather than an array. A list has an index like we looked at, where there's something in the 0 position, something in the 1 position, something in the 2 position, like we looked at before. But a dictionary, I look it up with whatever keys I put in. So I'm choosing to say blah is associated to A and pineapple is associated to Z, or this person is associated to this speeding ticket, or this credit card number is associated to this order online. I'm not looking them up by their position in the object. I'm looking them up by what the key is. So if I were to put, go back to my list, wherever it was, yeah, let's just take this one. Maybe not, because that's just numbers. I take any one of my lists here. Okay, here we go. And I create a little cell to do this. So I take this list. I can look things up by their position in the list, right? So the 0 thing in the list is 1. The position 3 thing is this string here, blah, blah, blah. The position 6 thing is true. It's this thing here. These are indexed, which means I get them out by asking for them by position, because it's a list. But the dictionary is not like that. The dictionary, I get them out according to what the key is, and you put the key in when you create the dictionary. So it's just a different data structure. So this has got key value, and this key could be anything. It could be 0. If I wanted it to be 0 like this, and I ask for what's in the dictionary at position 0, not position, sorry, at key 0, I'm going to get the answer. But I could swap these, and it's still going to work. I'm just going to get a different. I have to ask for 1 now. Like that. Does that clarify what you were saying? Can we directly put a dictionary to another, or should it be done by keys separately? We're going to see how you can put things into dictionaries. So there's a few ways in which you can do that. You can put the elements in one by one by one, or you can build the whole dictionary all at once, or you can do it with a comprehension, which we're about to see. So I think just wait for the punchline on that. Okay, so I can make the dictionary myself. I could put more things into it. I could put this mapping, something like this, and if I ask for 1, 2, 3, I'm going to get this. You see? Whatever set of keys and values I want, and I can make it all at once like this inside these curly brackets, or I can make it like this, which is where I do a loop, and then I assign specific keys to certain values. So this makes an empty dictionary with no keys and values in it. And then this says, do a loop over k over 10 things from 0 to 9 it will go, and put into the dictionary in position k the square of k. So let's look at that. So this is mapping 0 to 0, 1 to 1, 2 to 4, and so on. If I make another one, I could ask, what's the square of 6, like that. Okay, it's 36. But it's not because it's the 6th thing in the list. There's no list. It's because it's the value associated to the key 6. I hope that clears it up. I think it's something where it becomes much clearer once you create one yourself on the terminal. I suggest just playing with it and try setting the keys and setting the values. Try making it with a loop and try making it with this pattern. And try not including 0 in the keys, and I think that will help you understand. So practice getting something out of a list by its position, and then practice getting something out of a dictionary by its key. And I think the distinction will become more clear. Okay, but in Python, unlike other languages, to make these association structures or dictionaries, I can make a comprehension that builds my dictionary. So someone's just asking me about whether keys are unique. Yes, they are. Otherwise, it wouldn't make sense, right? Imagine I was mapping a person to a phone number. It is possible a person would have more than one phone number, but it wouldn't be more than one object in Python. It would have to be a list of numbers. So a dictionary in Python maps one thing to one thing, one key to one value, and I can't have another entry in this dictionary that's got one mapping to something else. If I do that, and I ask for 1, it's going to give me only the last one. It's overridden it here. So if I say 1 maps to A, and then later I say 1 maps to Z, it only gives me the last one when I ask for 1. So the keys are unique in that sense. But it won't crash if you do that. It's a common cause of slip-ups because it will let you do that. It won't make an error for you. It will just return something that's very surprising. Okay, so we can make a dictionary in Python using a comprehension, which is a really nice syntax, which is just much neater. So this way we build the dictionary that maps a number here to its square here. But I can do that by a really similar pattern to how we made list comprehensions. So I made with square brackets when I was doing list comprehension, but here we're going to put braces. And we say a brace k maps to k squared. So you can read the colon as maps to or is associated to. K is associated to k squared for every k in range 10. Bingo. This produces exactly the same dictionary that this one produced up here. So instead of making an empty one, looping over a range of things that can be confusing, and then looking at inserting them one by one by one, Python lets me do that in a much simpler way, in a one-line expression that kind of reads almost like a sentence. This says, make a dictionary which associates k to k squared for every k in range 10. So if we were to make a dictionary comprehension that maps numbers from 1 to 10 to their cubes, and I would say numbers 1 to 10,000 to their cubes, if you want to do it, it's just going to make a big output on my terminal. We do it like that, and just like before, if you open in Binder, just have a go. I'm going to go k maps to k, and remember, to the power in Python is double star. It's not the caret symbol like this, even no matter how much you might have that in your mind from C. So create a dictionary mapping the numbers from 1 to 10 to their cubes. So we're going to go for k in range. There we go. And the 10 will be not inclusive like we saw before, but the 0 will be included. And if we want 1 to 10 in the exact sense people normally mean it in English when they say that, you probably want 1 to 11 like that. And then we get 1 to 10 like that. So it's just always to remember that the first one in a range is included, but the last one is not. It's not inclusive at the top. So we can do many other things with this. Create a dictionary mapping a list of strings to their lengths. So here's a list of strings. I can say, give me a dictionary which maps the string S to its length for every S in this list L. There we go. So every string is mapped to its length. If I store that dictionary in a variable D, and then this might help the person who asked before, I ask about a string. So what about string 1? What's the length of that? So I'm not putting a 0 in here to ask for the first one or something like that. I'm asking for the one that's associated to string 1. So what is associated to string 1? So you can interpret this as like a sentence. Give me a dictionary associating S to its length for every string in this list. And this says, what length is associated to string 1? Please give me that one. Okay, so this was a puzzle that somebody gave me when I was in university, and I quite liked it. So let's Let's take a look, and I'm going to leave it with you with a hint for how you might solve it. Don't scroll down to the bottom of the notebook, because if you learn every topic in this notebook quite well, you'll be able to solve this with a list slice and a comprehension, and a dictionary comprehension. So my solution that uses both those things, I think it's as short as the one that I know how to make, is at the very bottom. So please don't scroll down unless you really want to see the solution. Okay, so Professor Genius is a strange person, like a lot of mathematics professors are. The professor likes to walk up and down a math department corridor, which has exactly 100 doors. So when the day ends, all the doors are shut, and the professor starts walking at the end of the day. So for fun, each night, Professor Genius walks up and down the corridor exactly 100 times. On the first time, walking up and back, the professor shuts or opens every door. So they open door 1, 2, 3, 4, all the way up to the end. The second time walking up and back, the professor opens or shuts every single door that's a multiple of 2. So door 2, 4, 6, 10, they switch it. If it's open, they shut it. If it's shut, they open it. The third time, they open or shut every third door. So 3, 6, 9, up to 99. And on the nth time, they open or shut every nth door. So they just walk up and down. If the door is open, they shut it. And if it's shut, they open it. So once they do this 100 times, which doors are open? So which doors are open by the time the morning comes? There's a mathematical solution to it that's a little bit surprising. But I suggest that you try and solve that as a code puzzle. If anyone thinks the question is unclear, just leave me a message in the chat and I'll respond. Try it a few different ways. Try to do it using loops and just keep guessing. Keep guessing the syntax if you don't get it. Python gives you very clear error messages, so it's going to help you figure it out by guessing. Will be the fastest way to become familiar with the syntax. And then once you've got something that looks like a step forward, try and work out how you could convert it to a comprehension in each place. It's a tricky puzzle for sure, but I think that just going for it and trying some things is the best way to learn this stuff. If you want to look at my solution, you can. It's at the end. If you want to go for the neatest way to do it, you might want to research the zip function and how to look at dictionary.items. But there are ways that don't need that if you want to just get the answer. So how you might try it, you could create a dictionary that maps the state of each door to whether it's open or shut. Maps each door's number, to whether that door is open or shut. And then find a way to modify that dictionary to represent the professor walking down the corridor one time. So like I said, this is a really tricky puzzle, and there's many ways to solve it. You could solve it just using a load of nested for loops. You could solve it a really neat way using a comprehension and a slice. And we're going to see slices, how we do those in 1 second. So I'm going to leave that one with you. And I suggest that even once you solve it, you keep looking for another way to do it, because I think it's a particularly instructive puzzle. Okay, so list slices. Python also provides some nice simple methods for selecting subsets of your data from iterables, that's spelled wrong, called slices. So this is another way to avoid unneeded or unclear looping in your code. So if I have a list, so this probably answers what the question. Yeah, of course.
Thanks. I will put into the chat his contact details and also, yes, exactly.
Yeah,
and also a form that he wanted to.
Yeah, I think I'll ask about that at the end if it's okay, Marta.
Yeah, very good.
Okay, so let's get as quickly as I can back to the monkeys. So we can select an element of a list according to its position by using square brackets with a number inside. And like the question as mentioned as well, we always start at 0 when we do that. So that is what you do for a list to get the first element, and it's a list because of these square brackets. A dictionary is going to look for the key 0, which is not the same as the thing in position 0. So I recommend just going through that painfully on the terminal yourself. We can use some other neat tricks in Python that are not so easy in any other language that I know. We can select elements of lists according to where they are in very neat little ways. So if I wanted the last element, that's going to be the -1 element, like this. So F was the last thing in my list. So we just start counting down from the other end. Something you need to do all the time, but other languages seem not to contain a neat way to do it. I normally have to reverse the whole thing or do some loop to get to the end or something. or use a built-in reverse function where I can't control what it's doing. But if I ask for something that's beyond the beginning, like this, I'm going to get an error, index error. So whenever you see index error, it means you've put something in these brackets that's too far outside the list. It's not in the list. So if I started here and counted back 100 steps, I'd go way off the end, and that's what it is. I started at F and did that. But in a dictionary, if I put something that's not there, I'm going to get key error. So those are the two differences to remember. With a list, it's going to be index error, and with a dictionary, it's going to be key error. You can also select ranges using a slice. So slices are ways to cut. It makes exact sense as a name. It's to cut a list up into pieces. So if I want to select all the elements, but starting at position 2 and going up to position 5, with the upper limit not included again, remember that's always the case. I can do it with this colon notation inside the list. So this is going to give me the thing in position 2. Remember, starting at 0, 0, 1, 2, 3, 4, and then we don't include 5. So it's going to give us those ones. So 2:5 does that. And you can see the 5th position is the F. And if we put the 5 here, we don't get the F in the list. I don't know if everyone can see my cursor. Actually, I hope they can, because I've been using it a lot. If I omit one of the numbers, say I omit the first one, it assumes you mean to start at the beginning. If I omit the second number, it assumes that you mean go all the way to the end. So this says start at 2 and go to the end. This says start at the beginning and go up to, but not including 4. So if I add a third number after my colon, within the slice, it tells me how I can step through the list, so the step size. So if I put start at the beginning, remember putting no number means go all the way to the end. So this says start at the beginning, go to the end in steps of 2. So it gives me every second element like this. This is a really a way to get that without looping, without checking if it's an even number or anything like that. We can just cut the list in even steps of 2. Or I could say, let me start at 1, go up to, but not including 4 in steps of 2. Or I could say, start at the beginning, go to the end in steps of -1. And that will loop through the whole list backwards, like this. And I could even say, go backwards in steps of size 2, or 3, or anything. This is a really nice, convenient syntax for cutting up lists, reversing them, stepping through them in different sizes, selecting subsets of them, that doesn't require any looping. And once you get used to the meaning of the colon, it reads almost like a sentence again. It says, take the list L, start in position 1, go to position 4 in steps of size 2. I find it far easier to understand what's happening using this syntax. So I can do this for any iterable thing. So if I make a string, murder for a jar of red rum, which is a famous palindrome expression, and I reverse it, you can see we get the same thing back again, except the spaces are not quite the same. So I can reverse a string this way as well. I can do a slice on a string. I can also do a slice on a string if I have this encoded message and I say start at the beginning, go to the end in steps of 2, so give me every second character, I can get my hidden message back out like that. And I can also, a really good one to remember, if you take nothing away from list slices other than this, is to reverse a list, colon, -1. Start at the beginning, go to the end in steps of -1. So what's the usefulness of this? So imagine we wanted to solve our monkey puzzle again. The 10,001 monkeys, they all line up. Just remember the puzzle. Each monkey is holding a number that is the cube of their position in line minus his or her position mod 1001. So what is the sum of the monkeys held in even positions in line minus the sum of the monkeys in odd positions? Well, using a list slice, I can just make a list of every single monkey's sign value like this, and I can say, give me all the even values. So start at the beginning, go to the end in steps of 2, sum that up, and then start at position 1, go to the end in steps of size 2. So these are all the odd monkeys, and sum up each of those two things separately. If I run that, you can go back and check we get the same number as we got before. So this is really the way to solve this problem in Python. This is a comprehension and a slice, which read almost as if they were English sentences once you know how to process the syntax, and which require no loops at all. You might say this is a loop inside of the algorithm. It does sometimes work with a loop, but in terms of the for loop syntax with a colon and nesting in Python, it's not one. So you can solve the monkey puzzle and get the same answer with a more efficient code that reads like a sentence in 2 lines in Python, rather than doing a big complicated loop. I think that's the take-home point from this whole lesson, is to, you can use Python as if it was like another language, but it's much better if you learn the Python-specific features that make it so intuitive, and that's what's making it so popular today, because it's simply easier to understand, so you can go further with it because of that. So let's just skip the slices of ranges thing and go to the conclusion. So the point is not that for loops or any other kind of looping are inherently bad. Sometimes it's essential. Not everything can be solved by comprehensions. You should use them to replace unneeded or confusing loops into more compact forms, and to avoid creating unnecessary intermediate variables. This will make your code more readable and intuitive for others, and also for yourself in the future when you come back to it. So that's, if you want to go through the way slices of ranges work, I suggest you do it as an exercise on your own. I think we're out of time to do it. So Marta, what do we do now?
Cool. I think that was a very nice explanation. Thanks a lot. Okay. I hope everybody enjoyed it. So I think we still have 2-3 minutes for a couple of last questions. Feel free to ask. Now it's the right time to do it. In the meantime, I want to thanks again Benjamin for this lecture and for supporting our cause, let's say. Yeah. Then I don't know, Ben, if you want to add a couple of sentences on also on the type of project you are doing that might be helpful for beginners that want to get into Python or more general data science.
Yeah, so my startup project now is creating a platform for beginners and experts who are learning data science or learning Python, but really data science, to practice puzzle-based learning on repeat. So a little bit like Duolingo or Memrise, but for computer programming puzzles. So I would say it's quite unlike and a synergy with existing training materials. You know, it's not something that I think will compete with edX or Coursera. It's not simply to deliver the content. It's to do specific puzzle-based problem-solving practice in a nice, easy, intuitive interface that constantly shows you new puzzles, and it only expands the puzzles based on what you've already been getting right. So a lot more the way Memrise teaches you a language. If anyone's interested in being on the beta test and being a beta tester for our development, it probably will be live in the next 3 to 6 months. There's obviously a lot of work going into that. And if you wanted to help me out, you could fill out the form that Marta just sent. It's just a very quick survey. It should take 2 minutes at the very most to help us understand our demographic. And something we specifically want to understand is what would make our platform friendly and inclusive for women, because a great number of young women now want to become data scientists, and there's clearly some reason why existing platforms like Stack Exchange are not attracting them or are not helping them to learn. So if you have any specific feedback about that, that would also be very welcome, because it's something that we're thinking about. So that's everything I had to say. And if you want to try and solve that puzzle yourselves, if you email me the solution, I'll be very happy to let you know if it's correct, or to give you pointers for how you can improve it. But my number one advice is just to start doing it, and not to worry about being wrong, or not to worry about. It might be frustrating at the beginning if you try diving into more advanced stuff, but I definitely recommend it as the fastest way to learn. It's just to address small puzzle-based questions and to play with them, rather than to try and work through some more formalized system. So that's everything I had to say today, and I hope everyone enjoyed it. Thanks very much for coming.
Yeah, thanks again to you, and thanks to all of you, ladies and gentlemen, to be here and to join us for this webinar. And we will probably host more webinars in the future. So if you want to hear other news from our side, just join our social media, both on LinkedIn, on Instagram, on Facebook, on Twitter. or on our website. Okay, thanks to everybody.